Hello, my dear students. So, how are you all? I hope you all are doing well. I am Bhaganti K. Patel, your dedicated chemistry faculty, committed to guide you and prepare you for your CET examination. So, today we will be discussing about solutions chapter class discussion questions. So, without any further wait, let us start solving all the 20 questions quickly. So, the question number 1 is in osmosis, involved solvent molecules moves from lower concentration to higher concentration. So they are saying that in osmosis what will happen? Solvent molecules from your lower concentration region to move towards the higher concentration region. So during osmosis, whenever you're talking about osmosis, remember about your pickle just. So your salt concentration will be high in your solution and the water concentration will be high in your cucumber. Okay. So what will happen as per days passes, your cucumber will shrink. That means water molecules have moved from your pure solvent lower concentration region to a higher concentration region. That is true. Next, two solution having same osmotic pressure are called isotonic solution. Yes, if they have same osmotic pressure, that means they are isotonic solution, but that doesn't explain about the movement of your solvent molecules from lower to higher concentration. So as they want it to be having the equal of pressure, they tries to move it. Okay, but that they have not given. They are talking about your isotonic solutions definition. That is not true. So the correct option will be what if both assertion and reason are true, but reason is not the correct explanation of your assertion. Next, if a solute is more volatile than the solvent, then vapor pressure of the solution may increase. So let's say if you have having a solution of a solute and a solvent. So here when we talk about relative lowering of vapor pressure, we clearly say that the solute must be what? Non-volatile. But in this particular question, they are saying that the solute is more volatile than the solvent. So now what will happen during the solution is, as the solute is more volatile, now more number of vapors will be formed and therefore the vapor pressure will start to increase. So you can clearly say that the vapor pressure of solution will be greater than your pure solvent. But the next statement which is given, in the presence of a more volatile solute, only the solute will form the vapors and solvent will not. That will not happen. Solute and solvent both will form vapors. Solvent will not form vapors. That is not true. Only non-volatile substances, non-volatile solute and solvent will not form vapors. But here clearly it is mentioned that the solute and solvent are both volatile. But the volatility of your solute is very more. Okay, so both will form vapors. So statement 1 is true, but statement 2 is wrong. So option number C will be your correct option. Next question. If 1 molar of your calcium chloride and aluminium chloride in water have boiling point T1 and T2 respectively, then they are related as what they are saying. So when you talk about boiling point, it depends upon your solute, correct? So boiling point, elevation in boiling point is directly proportional to your Van Hoff factor, correct? And your obviously molarity. So as your molarity is same here, obviously the concentration is same. Then it is directly proportional to your I value, correct? So here Van Hoff factor I represents about the number of ions when they dissociate or associate. When it dissociate, it will form 1 calcium ion and 2 chloride ions. So totally I value will be 3 for this case. When we talk about aluminium, it will dissociate into Al3 plus ion and 3 chloride ion. So totally 4 particles are there. So as I value increases, its boiling point will also increases to the more extent. So clearly aluminium trichloride AlCl3 which is having temperature T2 will be higher. So you can say T2 is greater than T1. Next question. Which of the following solution will be isotonic at same temperature? So which of the following solution is isotonic? They are asking. Isotonic means the osmotic pressure must be same. As they are saying same temperature. So here you know that osmotic pressure is equal to I into CRT. R is gas constant and temperature is same. So this value is whole constant. So what we have to compare? We have to compare the value of I and C. Correct? So here let us move towards the options. So here first one is given 3.42 grams of sucrose per liter. So per liter is given, volume is 1, correct? So 3.42 grams of sucrose, that means you can see concentration will be equal to number of moles here. So I value for sucrose is, it is non-electrolyte, it will be 1. So for N value, what it will be? So here IC, you can written it as 1 into 3.42 divided by molecular mass of sucrose is 342. So which is equal to what? 0.01. Now let us talk about the other case. So here they have given 0.8 gram of glucose. Glucose is again a non-electrolyte, so I will be equal to 1. And here the gram is given, so here value of IC will be equal to 1 into 0.18 gram. Molecular mass of glucose is 180. So how much it will be? 10 raised to minus 3. So it will be 0.0001. Correct? So this value you will be getting here. Next, let us talk 0.001, sorry. 001. Now, as they are not equal, they are not isotonic, then option number B, let us see. So 3.42 grams of sucrose per liter. So again its value will be what? We have already calculated 0.01. Next, 0.8 grams of glucose and 0.1 liter of water they are saying. So here the value will change definitely. So here IC will be equal to what? 1 into 0.18 divided by 180, and 0.1 liter is given. So divided by 0.1. So 0.001 divided by 0.1 will be equal to 0.01. So here IC value is what? Same. Therefore they are isotonic. Option number B is your definitely correct option. Let's see the other options also. So here also 3.42 grams of sucrose per liter of water. Again IC value is 0.01. 0.585 gram of sodium chloride. So when I talk about sodium chloride, here I value will be equal to 2. So here IC will be equal to what? IC will be equal to 2 into 0.585 divided by 58. So it will be what? 0.02, which is not equal. In next case, again 0.01 here, and here 1.17 gram of sodium chloride. So here IC will be equal to what? 2 into 1.17 divided by 58. So it will be giving you 0.04 value, which is also not equal. Next question. According to the given figures given below, identify the correct statement they are asking. So here when you observe this, you can clearly see that as weight increases, what will happen? Pressure will increase. So here pressure is less, and here there are 3 weights, so pressure is more. So when pressure is more, you can see that what is happening, the gaseous molecule which are present here, inside the solution they have moved less. So when weight increases, what will happen? This gaseous particle will come into the solution. Okay. So you know that according to Henry's law, as solubility is directly proportional to your partial pressure. So when pressure increases, solubility of gas in liquid increases. So you can clearly see that solubility of gas in one will be lesser. Okay, as pressure is less, solubility will also be less. As pressure is more, solubility will be more. So solubility of gas in beaker 1 is less than that of beaker 2. Option number B will be your correct option. Next question. Sprinkling salt helps to clean snow-covered roadways in the hills. The phenomenon involved in the process includes what? So when a non-volatile solute is added into your solvent, what will happen? There will be a depression in freezing point. Correct? Freezing point is depressed. The depression in freezing point occurs. So therefore what will happen is it will start to melt quickly. Okay. So as it is starting to melt very quickly, you can clearly see that when you spark salt around it, which is non-volatile solid, on top of that I value is 2. So here depression in freezing point will be occurring, and the more depression of freezing point will occur. So freezing point will decrease to greater extent, and therefore it will start to melt easily. So the correct option will be depression in freezing point of your snow. Next, Which of the following formulae of I is incorrect? They are asking. So I is nothing but your Van Hoff factor. So here the option 1 is given, observed colligative property divided by expected colligative property. That is true, definitely. So observed colligative property will be differ due to the value of your I, because here on adding solvent to a solution, it may dissociate and associate, therefore value will differ. Next, normal molecular mass divided by observed molecular mass. So that is also true. Number of molecules actually present, so which were actually present, and number of molecules expected to present. That is, expected to present will be what? Without dissociation and association. Actually present of what? After dissociation and association. Total number of particles taken before association and dissociation? No. It is taken after association and dissociation has occurred, divided by here before will be there. So the wrong option is option number D clearly. So option number D is your wrong option. Next up, which of the following azeotrope is not correctly matched? They are saying. So here HNO3 H2O maximum boiling azeotrope, HNO3 HI minimum boiling azeotrope, HC2 H5OH acetone minimum boiling azeotrope, chloroform and carbon tetrachloride minimum boiling azeotrope. So here you must know that always minimum boiling azeotrope will be formed by which of the following? Boiling azeotrope is always formed by your positive deviation showing combinations. Okay. Next, maximum boiling azeotrope, whoever show the negative deviation towards the Raoult's law, it will be showing maximum boiling azeotrope. Okay. So in minimum boiling azeotrope, as it is showing your positive, that is a deviation towards the Raoult's law, here volume must be increasing. So here what must having in minimum boiling azeotrope? Here hydrogen bond must be breaking, and here hydrogen bond must be forming usually. It is a usual case. Now we will consider the given options. HNO3 in presence of H2O, they are saying the maximum boiling azeotrope. Yes, it will be maximum boiling azeotrope because there will be a hydrogen bond between them. That is true. HNO3 with hydrogen iodide, it will definitely form hydrogen bond. So it is not minimum boiling azeotrope, it will form maximum boiling azeotrope. Next, alcohol in presence of your acetone. Acetone will hinder the hydrogen bond which are present in your alcohol. So minimum boiling azeotrope, correct. Chloroform and carbon tetrachloride, yes, it is minimum boiling azeotrope. Again, what will happen? Your hydrogen bond will be hindered. So option number B is your incorrect. Next question. At 27 degrees Celsius, the osmotic pressure of sugar solution is 500 Thor. So at T1 temperature, the osmotic pressure is pi 1, okay, 500 Thor. The solution is diluted. You are adding water, that means you are increasing the volume with same number of moles of sugar. So here, the temperature is raised to 927 degrees Celsius, that is your T2 temperature. The osmotic pressure is found to be what? 250 Thor. So it is your pi 2. The extent of dilution they are asking, that is they are asking about V2 divided by V1. So clearly, as you know that osmotic pressure pi is equal to nRT divided by V. So here, these two are constant, only T and V are being changed. So you can consider here pi 1 divided by pi 2 to be what? Your T1 divided by T2 multiplied by V2 divided by V1. So you need this value. How you can get it? You can get it V2 divided by V1 will be equal to pi 1 divided by pi 2 multiplied by T2 divided by T1. So what is the osmotic pressure here? Pi 1. So that is your 500 and pi 2 is 250 multiplied by T2, that is your 927 plus 273 1200 and 273 plus 27 is 300. So this got cancelled. 3 4s are 12, 252s are 4 2s are 8. So how many times you have increased dilution? By 8 times. So option number B will be your correct option. Next question. How much oxygen is dissolved in 1 liter of water? They are asking. So volume is 1 liter at 298 Kelvin. They are saying if the partial pressure of oxygen is 0.5 atmosphere, and KH value is 1.4 into 10 raised to minus 3 mole per liter per atmosphere. So as we're talking about how much oxygen is dissolved, so you know that solubility S will be equal to what? Your partial pressure of oxygen into KH, as KH is mentioned in what? Moles per atmosphere, liter per atmosphere. That means the solubility is in terms of what? Molarity. So here you can write number of moles divided by volume in liters into pressure, partial pressure of oxygen into KH. Right? And number of moles you can write weight divided by molecular mass into volume in liter is equal to PO2 into KH. As you are talking about the weight, how can we calculate the weight here? So simply weight will be equal to partial pressure of oxygen, value of KH and molarity into your molecular mass into your volume. So it will be what? 0.5 into 1.4 into 10 raised to minus 3, 32, and what is the volume is 1 liter. So it will be just simply 1, and you will be getting how much? You will be getting 22.4 the milligrams. So the correct option will be what? So 22.4 milligrams. It is present in option number A. Next question. The mole fraction of ethyl alcohol and water in solution, they are asking mole fraction of what? Ethyl alcohol and water in solution. If 23 gram of ethyl alcohol of molar mass 46 is dissolved in 54 grams of water of molar mass 18. So clearly they are talking about your mole fraction. Mole fraction of your ethyl alcohol would be what? So mole fraction of ethyl alcohol, it will be equal to number of moles of your ethyl alcohol divided by number of moles of your ethyl alcohol plus number of moles of your water. And we talk about mole fraction of water, it will be simply number of moles of water divided by number of moles of ethyl alcohol plus number of moles of water. So you need now number of moles of water and ethyl alcohol. Ethyl alcohol number of moles will be what? 23 divided by 46 here, correct? So 23 divided by 46 will be equal to 1 divided by 2, correct? So 1 divided by 2 is nothing but what? 0.5. And 54 grams of water they are asking. So here how much will be 54 divided by 18. So it will be equal to 18. 3s are 58. So 3. So what you will be getting here mole fraction? So it will be your 0.5 divided by 3.5, which will be equal to 1 divided by 7, and 1 divided by 7 is nothing but about approximately equal to 0.14, and this will be equal to what? 3 divided by 3.5, which will be giving you 6 divided by 7, and it will be approximately equal to what? 0.8. So the correct option will be your option number D. Next question. Which of the following pairings of solution have distinct physical state of solute? So the solute must be different here. Which solute? So solute's physical state must be different. It must be solid, liquid or gas. That kind of difference must be there. So here we can see homogeneous mixture of chloroform in nitrogen gas. So homogeneous mixture of chloroform in nitrogen gas is an example of liquid in gas solution. Liquid in gas. So solute is what? Liquid. And carbon dioxide in water. So here gas, carbon dioxide is gas, gas in liquid, it is an example. So here solute is gas. So clearly the physical state is different. So option number A is your correct option, but we will see the other option also. So brass, if you are talking, it is your solid in solid because it is an alloy. So here solute is what? Solid. Homogeneous mixture of your camphor in nitrogen gas. So it is an example of your solid in gas. So here the solute is solid. Both are equal. Sodium amalgam and moist air they are talking. So it is an example of liquid in solid. So here solute is liquid and it is an example of liquid in gas. So solute is again liquid. Solution of hydrogen gas in palladium. So it is example for gas in solid. So here the Solute is gas and mixture of N2 and O2, that is example for gas in gas. So solute is again gas. Next question. What is the Henry's law constant of dissolved oxygen at 10 degrees Celsius at 1 atmospheric pressure if the partial pressure of oxygen is 0.25 atmosphere? The concentration of dissolved oxygen is 3 into 10 raised to minus 3 mole per dm cube. So how you will calculate actually solubility? So solubility is nothing but Kh into partial pressure. Here oxygen is given, so oxygen. So as you're talking in terms of your concentration, and in option also, the Henry's law constant is given in terms of your mole dm cube. So here solubility is talking in terms of your what? Molarity. So molarity is given clearly. So here Kh can be simply equal to solubility divided by partial pressure of oxygen. So solubility is given as 3 into 10 raised to minus 3 and partial pressure is given as what? 0.25 atmosphere. Correct? So here how much you will be getting? So you will be getting here 12 into 10 raised to minus 3 mole per dm cube per atmosphere will be your correct option. So option is option number C. Okay, so next let us move towards the next question. So colligative properties are applicable to which one of the following solution they are asking. So when we ever talked about colligative property, we said that the solution must contain what? Solute, non-volatile, and the solution must be very dilute, because whenever the dilute solution will be there, what will they behave? They will be behaving as an ideal solution. Because we need ideal solution, it must be an dilute. Okay, so the correct option will be what? Ideal dilute solution. Yes, if you dilute it, it will become ideal. Option number A is your clearly correct option. Non-ideal concentrated solution. Concentrated solution will never work for your colligative properties. Non-ideal solution, so no, we are diluting in order to get an ideal solution. So it is also not correct option. Ideal concentrated solution. Concentrated solution will not be applicable. Next. The vapor pressure of a solution containing, so the vapor pressure of a solution they are saying, it is 13 into 10 raised to minus 3 kg of solute in 0.1 kg of your water. So solute concentration is 0.1 kg. At 298 Kelvin is a 27 mm of Hg. So its vapor pressure they have given. Given that the vapor pressure of your water at 298 Kelvin is 28 mm of Hg, the molar mass of solute will be water. So here you can talk about relative lowering of vapor pressure. So relative lowering of vapor pressure tells you, so the initial pressure minus pressure of solution divided by initial will be equal to what? NB divided by NA. So you can write it as WB divided by MB, A divided by MA. So here what you have to calculate the molar mass of solute, that is the value of MB. So what will be the value of MB now? So it will be simply equal to relative lowering of vapor pressure, that is P0 minus PS, that is 27 and 28, 1. 1 divided, so it is, let's say weight of this one is 1.3 into 10 raised to minus 3 kg, so 10 raised to 3 grams you can consider, into molar mass of your solvent, it is water it is given, so it is 18 divided by weight of your water, how much it is given? 0.1 kg, so 0. Into 10 raised to 3 grams you will be taking, and P0 minus PS is 1, and how much it is P0 value? So P0 value is given here as 28. So here 10 raised to minus 3 is given. What you must do, you can cancel these two out, and 0.1 is given, so it can be written as 10 raised to minus 1, and it will go up, so it will be 10 raised to 1, so it will be minus 2 here. Okay, so what will be the value of 1.3 into 18 into 28 into 10 raised to minus 2? It will be giving you 65 grams per mole. Next question. The value of Kb for a solvent is X. So here Kb value of a solvent, pure solvent, it is X. And a 0.5 molar solution of non-electrolyte, the solution, this solvent will boil at what temperature they are saying. So here elevation in boiling point. elevation in boiling point will be equal to Kb into your molality. Correct? So they are talking about a non-electrolyte in the solvent will boil at what they are saying. The solution containing a non-electrolyte. So here I value for non-electrolyte will be equal to 1. So here delta Tb as elevation in boiling point has occurred. So Tb of solution will be high and minus Tb of your solvent, which will be equal to what? Kb into your molality. Correct? So now the Kb value is given as x here. So it will be x now. So how you can calculate? So it will be Tb of the solution you have to calculate. So Tb of solvent they have given, that is A. So it will be x into molality is given 0.5 plus A. So x into 0.5 can be written as 1 divided by 2 will be equal to 0.5 plus A. So the correct option will be what? Option number C. Correct? Yes. Next question. The molar mass of solute may be estimated using the depression of freezing point. The correct formula for the same will be what? So molar mass calculation from what? Depression in freezing point. So depression in freezing point is given as a cryoscopic constant into molality. So how you can write molality? It will be number of moles of solute, that is here N2 divided by weight of your solvent. So how you can write it? Kf into your N2 can be written as W2 divided by M2 into W1, as it will be given in grams. You must take therefore 1000. Okay, kg. So this must be in kg. It will be given in grams, so you will multiply by 1000. So here M2 can be written as what? So Kf W2 into 1000 divided by delta Tf into W1. So which option is given here? Kf W2 1000 delta Tf W1. Option number D will be your correct option clearly. Next question. Which one of the following concentration term is not affected by temperature? So you know that PV is equal to nRT. So here volume is directly proportional to temperature. So any concentration term which contains volume, it will affected by temperature, and the which one is not containing volume, it will not be affected by temperature. So out of this, molality doesn't contain your volume term, as it is your weight, number of moles of solute divided by your weight of your solvent. So both are weight, no volume term is there, so therefore it is independent of your temperature, while the other three contains your volume. Next question. When mercuric iodide is introduced to an aqueous solution of your potassium iodide, so what you are doing? You are adding your mercuric iodide with your aqueous potassium iodide solution, Ki solution. So then what will happen? They are saying. So initially we will think that as mercuric iodide is there, so here it will be dissociated into Hg plus and I minus, and potassium iodide will be dissociated into K plus and I minus. So here expected I value is what? Your 4. But actual I value will be your 3. Because what will happen is it will form a complex. So as it is forming a complex, so it will be considered as a 3 because the complex formed here will be equal to K2 into HgI. So this particular complex will be formed. So here you can see it will be dissociated into 2K plus HgI minus. So you are getting a 3 components. So as I value is decreasing, what must happen to your boiling point and freezing point? So I value decreases, depression in freezing point will decrease, this value will decrease, and elevation in boiling point value will also decrease. So you can clearly see that elevation in boiling point decreases. So boiling point must be what is happening? It must be decreasing, and freezing point must be what happening? Depression in freezing point will occur. So therefore freezing point will be raised. So option number A will be your correct option, as freezing point is raised. iodide is introduced to an aqueous solution of potassium iodide, then what will happen? So mercuric iodide is nothing but HgI. When you introduce HgI with water, your potassium iodide Ki. So what will happen? So what do you expect? Expected I value will be what? Here there are two components, here there are two components, and they are both electrolyte, you will expect 4. But actually your I value will be 3, because when these combine, it will react to form a complex. So it will form K2HgI4 complex, and this will be dissociated to form your HgI4 2 minus. So it is forming what? 3 components. So as I value is decreasing, what must happen? Freezing point must increase and boiling point must decrease. So the correct option is freezing point is raised. Next question. If phenol dimerizes in benzene, which will have a Van't factor of 0.6, then the degree of association will be what? So they are talking about degree of association. Degree of association will be equal to what? Your I minus 1 divided by N minus 1. So I minus 1 is nothing but what? 0.6 minus 1 divided by, and N value, it is dimerizing, therefore N value is 2. So here 1 divided by 2 minus 1. So you are getting here 0.4 divided by 0.5. That is 4 divided by 5. Correct? So 4 divided by 5 can be written as 0.8. So correct option is 8. If a percentage of degree of dissociation is given, then it will be 18. Okay. So I hope you understood all the solutions. So keep solving, keep studying. All the best. Thank you.